Hey y'all, in today's video we're going to connect the rates of chemical reactions with stoichiometry. In the last video we looked at the rate at which butyl chloride reacts with water to create butanol and hydrochloric acid. Now, in the last video we only looked at the rate at which the butyl chloride was used, and we connected that to instantaneous and initial rates of the butyl chloride and of the reaction. Now today we're going to go ahead and take what we learned and use it to predict the growth or production of our product butanol. So the first thing to understand is that reaction rates are changes in concentration over time. If we are looking at a change in concentration of one reactant, the change in concentration of any other reactant or product is going to be relative to the coefficients in the balanced reaction. Remember, these are the mole ratios. So if they have a 1-to-1 mole ratio, like we do in the butyl chloride and butanol, the rate of change of the butyl chloride and butanol will be exactly proportional to 1-to-1. But be careful. I told you in the last video that rates of reactions are always positive, but that does not mean the rates of change of reactants and products are. Reactants go down in concentration. That's a negative change. Products, meanwhile, go up in concentration. That's a positive change. So the rate of change of butyl chloride and the rate of change of butanol will be the exact same magnitude, 1-to-1 relationship because of their stoichiometric relationship, but the butanol will be a positive value of change, whereas the butyl chloride will be a negative value of change. Remember, stoichiometry, the relationship is based off of a balanced reaction, the mole ratio. And in the case of reactants and products, reactants are going to go down. That's going to be a negative change. And products are going to go up. That's a positive change. Now we can graph this as well. If you look at these two graphs, or this one graph with the two lines on it, you can see that the line that represents the butyl chloride is exactly inverse of the line which represents the butanol. They both increase at the exact same rate, and they both level off in the exact same way, just in opposite directions. But this also holds true if the stoichiometry isn't 1-to-1. What if the stoichiometry of, let's say, this reaction, hydrogen plus iodide yields hydriodic acid, where it's a 1-to-1-to-2 molar ratio? In this case, the hydrogen and iodide would be used at the exact same rate. But the hydriodic acid would be accumulating twice as fast as the H2 and I2 are used. You can see that on the graph. The slope at any point in time of the HI, the red line, is going to be twice the magnitude of the slope of the blue line, which represents the changes of both H2 and I2. Remember though, HI is being produced, therefore its slope is going to be double and positive, whereas the H2 and I2 are going to be used, so their slopes are going to be negative. Now we can generalize the stoichiometry using this expression. This is a little bit more complicated than you need, but understand this. Even if we have multiple reactants and multiple products, the rates of change of any of them are going to be based around the stoichiometry. So if we have reactants, we're going to simply take the rates of change of those reactants, divide them by their coefficients, and make them positive, because their rates of changes are inherently negative, to get the overall rate of the reaction on a per mole basis. Okay? Products, we're going to divide by their coefficients, but leave them positive to get the overall rate of the reaction. So this is the first time we've ever been able to quantify the rate of a reaction. Essentially, it's the rate at which the reactants and products are created, in the case of products, and used in the case of reactants, but it's normalized to the reactions, the balanced reactions coefficients. So when we're looking at rates of reactions, that's one thing to keep in mind. That wraps up today's video. Today we learned how kinetics connects the coefficients in a balanced chemical reaction, or the stoichiometry, to the rates of change of both reactants and products, and then we finally defined the rate of the reaction. I hope you enjoyed this video, and I'll see you in the next one.